What is up, guys? Today we're going to talk about circles, and primarily 9.1a is just definitions of different parts of the triangle that we're going to talk about. After the break, we'll get into more computational stuff with circles, but today we're just going to talk about the general terms we're going to be using throughout this unit. Make sure you pay close attention. A lot of this stuff is written out for you. I'll draw some things along with it, but make sure you're really focusing on what's going on and you don't just skim stuff over. You have to know these terms. It's going to be important. All right, the first thing we're going to talk about is what is a circle. Well, a circle is a set of all points that are equidistant from a given point called the center of the circle. We all know what a circle is. We all have seen it before. The two big things that we're going to point out here is the two ways we're going to just call a circle or name a circle. And one way is just this circle P. We'll just write circle P. The other thing we can write is just a circle with a P next to it. That will be circle P. That being said, we're primarily going to use that one. We're just going to write circle P. It's just easier on the computer, and with all these notes, just write circle P versus the notation of it. But do be aware that you can write a circle with a P. Now, if I told you to draw a circle P, this is exactly how I want you to draw it. So you just draw a circle, and you would put a point in the center, and you'd put that point as P. That would be circle P, denoting that point in the middle tells you what the name of that circle is. Now, the circle is all of those points that are equidistant from that point P, just like our radius. Our radius is a certain fixed distance. All right, the next thing we're going to talk about is a chord. A chord is a segment with endpoints on the circle. So if I was going to draw a chord on P, all I'm going to do is I'm going to draw a straight line that touches 2 points of the circle. Anything that touches 2 points of a circle is going to be called a chord. So chords can be all over the place. You could have a chord over here. You could have a chord here. All of those would be chords because they do touch 2 points of the circle. The next thing we're going to talk about is a radius, plural radii. It's just a segment with endpoints at the center and on the circle. So we're going to have a point that goes to the center and comes out to the edge of the circle just like that. So that is a radius. So this is my radius. This would be a chord because it does touch two things. And this would be circle P. All right, the last thing we're going to talk about is a diameter. A diameter is a very specific chord, so it touches both sides of the circle, and it's going to go through the center of the circle. In fact, it's going to cut a circle in half. So if you look kind of at the bottom right, the diameter for this one would be that DE. It's a chord because it touches both sides, and it goes to the center at C. That would be a diameter. A diameter is, in fact, twice as long as a radius. It's, in fact, two radii put together. All right, that is going to be our diameter. So going back to that picture I just drew on, let's name some chords. Some chords would be AB. We're going to put segment AB, and the other chord would be DE. So a diameter is, in fact, a chord. So if I ask for it, is it a chord? It is, in fact, a chord. Some radii, we have CF. We also have CE. And finally, we have CD. Those are all radii. CD. The last one just asked for a diameter. There's only one diameter on there, and that would be the segment DE. Now, the order in which I name it doesn't matter. You could call it ED. Down below is just what I just said. A radius is half the length of a diameter. It's two diameters put together. So a radius equals diameter divided by 2, and a diameter equals 2 radius, or radii. All right, now with circles, there's something called circle pairs, and that's when we're comparing two circles to each other. There's certain ways we can draw circle pairs. The first way is two circles are congruent to each other. So we're talking about congruency, similarity, and other relationships. So the first one is two circles being congruent. Well, the only way they can be congruent is if they have congruent radii. So in the two circles below, if GH is the same length as JK, then the two circles are in fact congruent to each other. This will also work with a diameter. If both the diameters are equal, then both the triangles are congruent. The cool thing about circles are all circles are in fact similar to each other. So we'll never prove that two circles are similar. They just always are similar. The last thing is kind of a special case, and it's called concentric circles. These are coplanar circles that have the same center. So if we look at our example, we have a circle A with radius AB, and we also have circle A with radius AC. Those two circles are concentric because they have the exact same center point. So a lot of times they'll have the same name. So we'll use the radius to determine which circle we're talking about. Lastly, two circles can intersect in two different ways, and they can also not intersect at all. So the first way is a circle intersecting at 2 points. So if I have a circle here and a circle here, they intersect at 2 points. The other thing that can happen is they can intersect at 1 point, which would look something like this. Nope, and then they're going to do it. That's going to be a big circle, but something like that, where it intersects at one place. Finally, no intersection point, not really interesting. You just draw two circles. They don't touch. They do not intersect. This kind of goes with our concentric circles as well. Our concentric circles are kind of a way that circles can intersect. So these do not intersect. So this one would in fact fit right there. They do not intersect. Even though they're overlapping, they would be part of that do not intersect at a point. All right, angles of a circle. These are really, really important because we're going to start talking about sizes of these and how they relate to different arcs in it. So you really have to get down what a central angle is and what an inscribed angle is. A central angle is an angle with a vertex in the center of the circle. Note on this drawing, if you have a central angle, you have two radii. So both of these would in fact be a radius. So a central angle has two radii that make it up. So that's a central angle. It goes to the center point and it goes out. And a lot of times we'll just end it here where I'm putting those red dots. A lot of times we'll just draw it there, and that would be the end of it. All right, the next one is inscribed angle. An inscribed angle is an angle that has a vertex on the circle and sides that contain the chords of the circle. So if you look here, B is actually a point that's on the circle. It's not on the center. It's actually on the outside of the circle or around the edge of the circle. Then you would connect two chords. So you can see BC is a chord and BA is a chord. So that's what's going to make it an inscribed angle. So once again, central, it ends at the center of the circle. An inscribed angle goes all the way to the back end of the circle, and it uses chords. So inscribed angle, chords. Central angle uses radii. Now arcs. Arcs are going to be how far around the circle you go between the points. So a portion of a circle that's defined by two endpoints. The first one we're going to talk about is a minor arc. A minor arc is the shortest arc connecting two endpoints of a circle. So if we look at our little drawing, that minor arc right here is that distance between A and B. That would be our shortest distance between the two. When we are naming a minor arc, we're going to use two letters. So in this case, when I'm talking about minor arc AB, I'm just going to denote it as AB, and I'm going to put a little arc symbol above it. This little arc above it just stands for I'm talking about an arc. And because I'm using two letters, it's going to be a minor arc. So in fact, that minor arc would just be this distance here from A to B. A major arc, on the other hand, is the longest arc connecting two endpoints of the circle. So if we go back to AB, we said the minor arc was this distance because it's the shortest. Our major arc is going to be the one that goes all the way around the opposite direction. So it's all of that. When naming a major arc, you need to have three letters. And when we're naming this one, we're going to call it ACB with C in between A and B because that's where it shows up on the circle. And once again, we're going to put the arc above it. So arc just stands for I'm looking for an arc. 3 letters tell me I'm looking for a major arc. And that major arc would be all the way around, would be something like this. We'd have A and B there. In general, a minor arc is going to be one that's less than 180 degrees, and a major arc is going to be the one that's bigger than 180 degrees. All right, somewhere in the middle, I usually call these major arcs, but according to our book, we have minor, major, and then we have something called a semicircle. That is an arc with endpoints that lie on the diameter. So once again, it is an arc with endpoints that lie on the diameter. It's going to create a semicircle. So if we look to the right, when we're connecting D to E, that is half our circle, because if I'd come down here, that would also be D to E. They'd be the same size. They'd be exactly 180 degrees. When naming a semicircle, you can either use 2 or 3 letters. I usually just use 2 letters. And I do that because it is the distance from D to E. No matter which direction you go, there is no longer or shorter distance, so you don't need to delineate which direction you are going. So I'm just going to name a semicircle with DE, knowing that it cuts the circle into a semicircle, which is also called a hemisphere. Cuts it in half if it was a full sphere. All right, the last thing we're going to talk about here are intercepted arcs, and that's just an arc created by an angle. So if we have an inscribed angle, and we draw our lines, you can see with these blue lines here, they actually, let's change that to red so we can see what's going on. So I'm talking about these chords. They're going to create an arc that's like that size. So when I'm talking about intercepted arc, it's just when we have like an inscribed, a central angle, some kind of angle that creates an arc on the other side. Generally speaking, if I'm talking about the intercepted arc, it's always the one between the 2 lines, so right here, versus talking about this arc here. If I want that arc, I'm going to specify that I want the outside one, but inscribed just means in between the 2 lines. All right, continue on. Last big thing is tangent. Tangent, all that is a line that touches the circle in one place. A chord touches in 2 places, tangent touches in 1 place. So the definition here, a tangent, a line that intersects the circle in exactly 1 point is called the point of tangency. Note, it never goes inside the circle, it just bounces off it right here. If it ever goes inside of it, we're talking about a chord. For instance, if I'd move this over at all, that would be a chord because it's hitting in 2 places. So tangent, the way I look at it, just kind of grazes the side of the circle at 1 point, and then you have a tangent. The point that it hits the circle, that is called your point of tangency, which is right here as well. Your point of tangency is just where the 2 things intersect. All right, that is what tangent is. Now let's talk about tangent when we have 2 circles. So we have 4 different types of tangent lines when you have 2 circles. The first one is if you have 2 circles that are touching, an external tangent is going to be one that goes right smack dab between the 2 of them. An internal tangent is when you have a circle inside of another circle, but they do touch here. So in fact, your tangent is touching in 1 place on both circles, but 1 circle is inside of the other one. So it might look like, let's call this one A, let's call this one B. How I might state this is I might say circle A is internally tangent to circle B. And then I might also say that that line is tangent to both of them. But that's what I mean by internally tangent. They touch each other with one being inside, where the other one is they're touching on the other side. So if I would name the one to the left and I had A and B, this would look like circle A is externally tangent to circle B. All right, the next ones are if the two circles aren't touching at all. So if we look at these bottom two ones, they still use external and they still use internal. However, they say external common and internal common. So these two circles aren't touching at all. However, if you have two circles that aren't touching at all and your line kind of stays on either the top or can come through on the bottom like this, both of those lines are considered external common tangents. They stay either above or below. Picture you can also turn it the other direction. For example, if I had a circle here, a tangent line could also go like that. It's just staying on one side of both circles. If that line kind of crosses in between, so it's on the, if you look at the right, on one circle it's on the bottom, one circle's on the top, this is called internal common tangent. A good way to look at that is if you would connect both of these circles with a line like that, your internal tangent would cut through that line, your external tangent would not. All right, so that's internal, that is external common tangents. These are all the phrases we're going to be using in just a little bit. And in fact, we're going to actually do one homework problem together to kind of see what we're trying to do. The bulk of this assignment is I'm going to describe something to you and you have to draw it. We're not all going to have the exact drawings, but we're going to have ones that are close enough and represent exactly what's being said. So the first one says circle A with, and in fact, I'm going to stop right there. As soon as they list a circle, go ahead and draw that circle. So circle A is going to look something like that. It's just a circle with A in the middle. All right, then it says there's going to be a chord BC, and it needs to be tangent at CE. So let's start with a chord. A chord can be anywhere you draw it. I'm just going to draw it right here. All it has to do is touch both sides of the circle. And it says it's chord BC, so I'm going to name one of the places it hits and the other place it hits as well. Now, if we look at the next thing, it says that I'm supposed to draw a tangent line CE. I cannot create a brand new C, so I have to use that C I just used. Well, that must be the point of tangent C. So I'm just going to draw a tangent line that goes through C, and I'm going to name some point in the line E. Well, that is definitely the line CE that is tangent to the circle at point C, and we have a chord BC. So make sure after you do your drawing it matches everything that's set up here. Once again, all of our drawings aren't going to be exactly the same, but we'll work on that tomorrow. That's why we're doing it in class tomorrow. All right, that is the long and short of the beginning of circles. Just as a reminder, tomorrow will be a work day on this homework, so hopefully you watched it and you're ready for tomorrow's class.